All right. Hello, everybody. Good morning. It is a beautiful day in Portland here. I suspect it's one of the last beautiful sunny days we will have before the rainy season. So I hope all of you are having a similarly awesome day. Um, I need your help this morning. I'm gonna have you all vote on what demo we do for the first half of the live stream here. So I'm going to put this in the chat and I'm going to describe these, but here's here's the voting outline. So I've got three different things that we could walk through for the demo for the first part of this, and that's the first one is an Esri blog summarizer, which is a thing that I've done before. Um, and a thing that I've talked about in my newsletter and maybe even in one of these previous live streams, but there's nice ways to build those kinds of processes now using AI first automation frameworks like N8N. So we could walk through that. Last week for my newsletter, I did a multi AI image data extraction process, which is basically the idea that an AI might get something wrong, but if I use two AIs to extract the same information and they agree, then I can be super confident that that's right. So we could walk through how those processes work. Or for next week is Dymaptic's company retreat. So we're off doing that next week. Everybody's going to be here in Portland, so that's going to be super fun. Oh, I posted it to the wrong thing. Thanks, Holly. Um, so the last one is one night, instead of all having dinner together, we're splitting up into a few different groups and going to different restaurants around Portland so that everybody gets a different experience. And the assignments are random. But there's an AI that you can talk to get yourself swapped or moved to another restaurant. So we could walk through how I built that. So those are the options. So open up your chat, and if you want to see the Esri blog summarizer, that's a little newspaper emoji. Or if you want to see the multi AI image data extraction process, that's a little picture frame emoji. Or if you want to see the dymaptic retreat food decider arbitrator, that's a little pizza emoji. So drop your preferred emoji in the chat here, and uh, yeah, so we'll dive into that in just a minute. I guess in the meantime, I've got the whisper frame up and running here. Uh, yeah, it's apparently I was in a meeting recently where there were a lot of sticky notes for things I didn't need to that I don't want to forget. And I need to fix the printer multiple times. That is not a true thing. I do not need to fix the printer. Um, yeah, so what else? Let's see, what else is going on? Maybe, you guys can probably see in the background some power tools over here. I'm getting ready for uh, my Halloween extravaganza this year, which is a giant prize wheel. Prize wheel itself is like almost a meter across. It's like about that big, kind of literally. And you spin the prize wheel, and it lands on a wedge, and then up above you there's a second big disc that has a bunch of cauldrons, and the cauldrons have candy or other things in it. I'm thinking one of them maybe has like a bag of carrots because that might be funny. And depending on which wedge you land on, the whole thing kind of spins around and then drops drops the cauldron worth of candy or carrots or whatever on top of you, so that you get your prize. And then I have to stand out there on a ladder and reload it periodically, or maybe constantly. I don't know. But anyway, that's super fun. There's very little AI in it, but Claude has been helping me write the code for that. Um, Definitely, and it's definitely sped up my integration hell process. Integration hell is a term that I got from one of my all-time favorite YouTubers, Stuff Made Here. He builds absurd contraptions, and he calls integration hell the process of, well, I made all of the hardware and I made all of the software, and now I have to make all of this work together somehow. And it's that process of iterating and trying to fix and make everything kind of go um, all together. And and so this is I haven't done a big project like this in a little while. The last one I did was my LED Christmas tree. This was last Christmas, which is on the wall over there. I need a mobile camera somehow. I need to figure out how to do that so you can show you all these things around. Maybe I'll do that next time. I'll do a workshop tour for the next live stream. Um, anyway, Claude played a big role in writing this code and kind of helping me through that process. Kind of course, it also caused some of that process. If you've ever written code for things like microcontrollers, you have pins, right? And each one of those pins might be connected to another peripheral, another device. It's like having a USB port, right? And you have to tell it which pin you're talking to or which pin you're reading from. And I had set it to 0 because that's where the thing was plugged in. And Claude really wanted it to be 1, and that is not where anything was plugged in. And I definitely spent over an hour troubleshooting this peripheral that was just not even plugged into the right port. So Claude has helped a lot. It has also caused more integration hell. So that's a fascinating tidbit to kind of take with you. And I think that totally applies to a lot of AI usage just kind of in general. Okay, so we got a couple of votes in here. Let's see. So we got a picture frame, we got multi-AI image data extraction, another picture frame, and then a news vote. Okay, so I guess we're gonna start with the picture frame. Okay, so let's get some screen share happening here. Screen share, desktop. There we go. Bring this back up so I can see. Awesome. Okay. So last week in my weekly newsletter, Almost Entirely Human, the episode was titled Trust But Verify. Verify. It's ridiculous, I know. And the idea is that 2 or more AIs are better than 1. And so the premise here is I have a picture. And in this case, in this example, I have a picture of a air quality sensor, which I actually have right here. It's one of these little guys. And it sits normally inside my 3D printer enclosure. I have a big setup for resin 3D printers, which produce a lot of volatile organic compounds that I don't want to breathe in. So I have extra filters and vents and everything to make sure that is not in my space. And that is behind over here. You can't really see it. You can just barely see one of the exhaust vents right there. But anyway, this normally lives in there, and it is cheap and does not have a way for me to access this information other than on the screen. So I wanted a way to take a picture of that screen and extract the numbers off of it. And so I might have like the 2.5 particle size, or my 1 or my 10 particle size. I might have the organic compound number or temperature, humidity, the overall rating value. But I want to get those numbers out of this image. This is super easy for a human, right? Any one of us could immediately look at this image here and would be able to extract all of those numbers with basically a 0% error rate. Maybe every once in a while, if I asked enough people, somebody might get confused about what is the PM10 reading. Maybe they would read that 10 as part of it. Maybe not. I kind of think not. But something that AIs do sometimes is get confused about what they're reading. And one common failure mode in this particular example especially is confusing the number that is in the label with the actual reading. And so it might read 10003 as the PM10 reading. It doesn't happen very often, but maybe 1 out of 5, 1 out of 10 times, something like that. And inconsistently too. So it might happen in different spots on the screen, but almost always where there's something confusing about what it's reading. And so one way I can do this, and I've talked about this idea before, is just I could read it multiple times. So the first time I talked about this was months ago when I talked about the idea of estimating calories in food, right? So if I have my phone and I take a picture of some food, I want to know how many calories I'm about to eat. And you can actually have AI estimate those calories. It's not 100% accurate on its own, but it is relatively accurate to itself, which is important. There's actually now apps that do this. When I came up with this idea and built my little proof of concept, there were not apps in the App Store that did this. Today, there's like a whole industry around this. So you're welcome, industry, I guess. Um, and so I could average those, right? And so if I'm going to take a picture of food, I'm going to get, well, this is 1,000 calories, 800 calories, is 900 calories. I want to take an average of those three, and that's probably close enough to what I want. In this case, taking an average would not be what I wanted. If I had if the reading number for this was 3 and the other reading was 10003, the average of those two numbers is not anywhere near right. So that's not really the process that I want here. Instead, what I want to do is I want to extract this data from this image, and I want to compare the results. And I want to see if they match. And so in this case, and I chose this example on purpose because it's very easy to see discrepancies, right? This is either 3 or it's not 3. And I know that that is the answer that I want. In more dynamic scenarios, I might have, a picture of some aerial imagery and say it was like of a building that had been impacted by a storm after a storm surge or after a fire or something like that. And I wanted the AI to estimate the amount of damage that was done, how much of the building is left based on just that aerial imagery shot. It's pretty accurate on its own, but it's more subjective. So it's much harder for me to say, oh, as a human, look at it and say, oh, well, I think that's wrong. But these same principles that we're going to apply here, you could use on data extraction for aerial imagery. Excuse me. You could use for reading things like serial numbers off of labels on devices. You could use it for reading documents and taking important content out of that document. Anything where you're going to depend on an AI to extract information, but what you care highly about the quality of the output. And so what we want to do here is we basically want to take this image and we want to run it through 2 different AIs and extract the data twice. And so I'm actually not even running it twice through the same AI, but we actually use OpenAI and Claude separately and extract each one's version of the image, each one's version of the data in the image, and then pull that back together and compare those results. So do these 2 agree? If they agree, then that's our answer. If they don't agree, then we want to go to an arbiter. And we want the arbiter, ideally, we'd want like a third AI model. So we could even, I didn't do this in my example, but you could even go to like Google's Gemini. So you have yet a third perspective. And in that third perspective, you're going to send the original image and the 2 different outputs, and you're going to ask it to judge what is the actual correct answer. And then you could do, another check after that, or you flag it for human follow-up or do something like that. But we're going to walk through this process a little bit here. So the way that I always prototype these things these days is using this workflow engine called N8N. And N8N is very much like a make.com or a Zapier or a Power Automate. The difference is it's AI first and it's bulk data first. So it can operate on many records in parallel. It is has native AI nodes that you can just wire through the process. It hooks to any of the major AI frontier models as well as some of the free models. You can subscribe to it online and use it on hosted servers, or you can run this yourself on your own infrastructure on your own network. So you have a lot of flexibility, a lot of options here. This is one of the reasons that I really like N8N. It also has a ton of integrations. So if I want to read a Google spreadsheet or download a file from SharePoint, or I want to send an email, or I want to read an email, I can do all of those things inside N8N just by configuring my authentication. So the way that this particular workflow works is I started with this form submission, and basically I'm just uploading an image. Okay, so when I upload an image, the first thing I actually want to do with that is I want to resize it. I want to size it down. And the reason for that is I took this image with my iPhone, and my iPhone has a tendency to take extremely large, highly detailed photographs. But I don't actually need all of that resolution for the AI to be able to read it. And actually, by making the image a bit smaller, I can speed up the processing time. I can save on tokens. I can save on yeah, I guess tokens and processing time. I guess that's really the things. But I can save on that by reducing the size of the image. And because I'm in this automation framework, I can just use the edit image tool. And so what this tool lets me do is resize the image down to 500 by 500. And that I can change that. I could test that depending on what I'm taking a picture of. I could even do something intelligent where I try it first to see if it's readable by an AI, and then go back and get a different size if there wasn't enough detail. You can do a lot of things in a workflow like this. But basically, we need to shrink it. So we're going to shrink the image down a little bit. Once we do that, we're actually going to branch into two parallel paths. So the first parallel path is using ChatGPT or OpenAI to extract the information. So if we open up this node here, and there's actually, we're just using our prompt here, our user prompt. So this is what that prompt looks like. And actually, we're using the exact same prompt for Anthropic and for OpenAI. The models are different though. So tweaking each prompt to each model can help. And I'll give you a tip on how to do that in a second. So basically what we're going to do is we're going to describe what it is that we're doing. We're describing what all of the numbers are and kind of their relative position. Like it's on the top, it's on the left, it's on the right, it's on the bottom. So that the AI kind of has an idea of where it's reading this information from. And we want it to provide information back in a JSON object. So we want it to give us our air quality and our TVOCs, our temperature, humidity. We want everything in that JSON structure so that we don't have to do any additional parsing. And then we also, I went ahead and I gave it one extra one so that there's an errors attribute. So if it was confused or didn't understand something, it could describe what it didn't understand. And that's really for further down the line when we do the arbitration step, because we want this, we want that, we want to give that arbiter information. So if the ChatGPT was confused because there was glare on the image, we want that information to get to the arbiter so that it has just more context about what it's doing. And then we tell it what to do if any values are not available, like null, and then provide details about problems reading it in the errors condition. So that's all the prompt is, right? It's really straightforward. You can refine these prompts significantly, but I think it's important to note that you can build a quick and dirty workflow like this in half an hour using very simple prompts like this. You don't have to go and study and read books or documents on how to prompt it. you can just describe like you would to a human that doesn't understand what it's looking at, describe what it should do. And that works really well as a first try. It works really well out of the box. So once I've done a prompt like this, if I want to make it specific to OpenAI or specific to Claude, to ChatGPT or to Claude, one really easy way to do that is to take this prompt, go to ChatGPT and say, I wrote this as a basic prompt outline for a task that's going to do image data extraction in ChatGPT. Please refine this to be a high quality system prompt that is fully compatible with OpenAI's API or ChatGPT. And it will rewrite this and it will embellish for you. Then you take that and then you edit that. Because it's not going to come out perfect. It's going to have red herrings. It's going to have things that you didn't mean. It might hallucinate new numbers onto that it needs to read or new units that it needs to parse. And so you don't need to take everything that it gives you, but it's going to give you kind of an architectural set of steps. And it's going to use the best practices that it knows because one of the things that OpenAI and Anthropic both do is they use their own models to write prompts better. So they're very good at that. So leveraging it to go from a basic prompt to a better prompt is a really good trick. Just make sure you're using that model to rewrite it for that model. So like use OpenAI to write it for OpenAI. Use Claude to write it for Claude. Don't use Claude to write it for OpenAI. It probably does know the best practices, but it's not trained to do that in the best possible way. Okay, so we have our basic prompt that describes what we're extracting and what the data structure is. And we're going to do that same prompt on both of these. So we're going to use that in ChatGPT. We're going to use it in Claude. Now, we told it to output in JSON. And most of the time, these models are pretty good at outputting structured JSON, but sometimes they're not. And so that's what this extra node here, the structured output parser, helps us with. So when we go and we look at it, we see what I've done is I've given it an example of what the JSON should look like. And behind the scenes, it's turning that into a well-known JSON definition. And then it's going to automatically parse that output when the AI is done and it returns the result. It's going to automatically pass that into a tool and parse that into this exact format. And if it doesn't fit, if it doesn't work, the AI did something wrong, then we turn on this auto fix. And I actually have the Anthropic model attached to this. I could have used ChatGPT. I just chose Anthropic because I was trying to test out 4.5, the newest model from Anthropic. And it's actually going to use the AI to rewrite it to get it in the right format and spit it out. So it's kind of, there's a little bit of inception happening there, but basically what we end up with is two different sets of data, one from the first model and one from the second model. And you can see in our example here that it actually read all of the numbers correctly. And then both of them actually identified that the TVOC field was saying wait and was not available. And then it also used 0 instead of null. So probably I'd have to go back and tweak my settings a little bit to make sure that it was nullable, but you get the idea for a proof of concept. And so here, basically, we're looking at the two different outputs one from each model. We can see that actually, in this case, everything fully agrees. So what we do from here is we do this compare process. And in this case, I've actually chosen to just write some JavaScript. And by write some JavaScript, I mean ask Claude to write some JavaScript for me. Because I don't remember what all of the parameters are that I can get in an innate end node. But instead, what I can do is I can go to Claude and I say, Claude, I have this output structure. I can go to JSON right here. I copy this, say, Claude, I have this output structure in N8N. Write me some JavaScript that will compare these two objects and tell me if they're true, if they are the same or not. And also make sure that you ignore the errors field because obviously everything else might be same, but the errors field is free-form text, so we don't want to compare that. And so it wrote me this code here, and you can see it actually made it generic, so I can exclude whichever fields I want by passing in the field name that I want it to ignore. And the output from this is just this little object here where it returns object one, it returns whether or not they are different, and it returns the compared with the object two. So I actually get all of the information out of this that I need. And so what that looks like then is when I go over here to our is different, is I'm basically just checking to see if is different is true. And if is different is true, I'm going to route that up to my review agent. And in this case, my prompt is actually super simple. It just says, these two inputs don't match. Try to resolve them. And here's the image. Grab that image after the resize and pass it into here. So one of the things about N8N is I can pass data directly, and that's kind of the path that these lines follow. But when I'm executing a node, I can actually access the data in any previous node by its name. So I can go back and I can get the image, I can do these different things and pass that on to my agent. If they were not different, if they were the same, then I just send myself an email. And I wanted to have a little bit of fun here. And so I created an HTML email that looks like, go back to my newsletter post. It looks a little bit like the original layout. And so what I did is I went to Claude and I took this picture here, and I took the N8N node or the N8N output, and I pasted that into Claude, and I said, create an HTML email that I can use that uses these variables that looks like the original UI. And it built that for me. And it was right here that I realized that I had some missed opportunities. Specifically, I noticed that when the AI made this, it put the battery symbol in the top right corner, just like in the original. There is a battery symbol in the top right corner. In the original, the battery is almost dead. It's very low. It actually died like 2 minutes after I took this photo. But in here, it's almost full. And so I looked at the HTML and it was just hard coded. But there's emojis that represent the fullness of a battery. And I think it's like super low, 25, 50, 75, full, something like that. Like there's a couple of set stages that I could use. And so actually what I could have done is way back here in my workflow, when I was extracting this information, we were looking at this prompt. I could have also said this image also contains a battery indicator in the top right corner that has a symbol that shows me how full the battery is. Categorize the battery symbol into empty or nearly empty, 25%, 50%, 75% full, and return that as an additional attribute. So I could have actually extracted that additional piece of information. I didn't go back and fix that, but I could. And I think that shows you kind of the power here is there's a lot of additional information, pictures worth 1,000 words inside that image that I could extract in addition to just reading those numbers. And actually, in the specific case, it even like the color of the numbers changes if it is, so if it's green, then it's in a good threshold. If it's yellow, then it's in a warning threshold. Like you should only spend a few minutes in the environment. And if it's red, like you shouldn't be here. So oh, thanks for coming, Ethan. See you later. So So I could have extracted that information. Also, I could have identified the color of the text in these three groupings, up here with my overall score, my HCHO, and my PM 2.5. Those have colors. And so I could have taken those colors and read that in also. So there's a lot of information that I can read from that. And what's cool is I don't have to do kind of that traditional image processing. So I could do this using like OCR, right? And I could even detect the color of those things. I've done a lot of that kind of work. It actually, an early version of my giant spinning wheel was actually doing something like that, where I was looking at the back side and trying to figure out what wedge I'm in, um, and doing some image processing, but on a device that doesn't have very much processing power. And so I could use those kind of traditional processes, but the downside is that, well, I guess the upside of those traditional processes is that they're very repeatable. The downside is that they're not as flexible. So in this case, if I mounted a camera right above this, my pictures are going to be very systematic. They're going to be very similar every single time. Everything's going to be within a few pixels. I could very easily describe that OCR algorithm in code. But let's say I am taking pictures of like the serial number or the tag on a hot water heater or something like that. I'm inspecting a home and I'm going to take a picture of that tag on the hot water heater. Every brand is going to be slightly different. There's going to be different amounts of reflection. There's going to be different lighting. There's going to be different camera quality. There's going to be all kinds of different things that are going to happen there. And it's going to be much harder for me to build a reliable kind of traditional OCR process that's going to be able to extract something like this is the serial number, this is the model number, because just the conditions are going to be very different. Whereas an AI is very good at that. And when it gets it wrong, I can combat that by using multiple AIs to read the same value and then merging those results together. So I think that the biggest things to take away from this are, one, building an N8N workflow like this is really straightforward. And there's a lot of YouTube videos, there's a lot of documentation, there's a lot of examples of different use cases here. But it's fairly straightforward to do. And it's incredibly powerful to not only build production systems, but to build a proof of concept. You can spend a half an hour or an hour building a workflow like this and testing out like how good is it? Of course, you can also just go to the ChatGPT app and drop an image in it, write a prompt like this, and see what it returns. And if just dropping that image into ChatGPT or to Claude gives you back kind of what you're looking for, then that's going to work. So that's typically where I start, is I'll just toss it into Claude or ChatGPT and see if it works. Does it do kind of what I'm expecting? If it does, if it looks positive, then I'll go to something like N8N and start building this out. And before I even go to writing code. Yeah. So takeaways from this are that this is really easy way to get started. It's a really easy way to build out a proof of concept. There's a lot of integrations that you can connect to a lot of systems. There is not an Esri integration, but the REST endpoints are really straightforward to call. So I've definitely done that. Last live stream, we looked at the fantasy map generator, and that was reading and writing GIS data. It was being triggered by a webhook from Survey123 and going through a bunch of things. It was getting a token for authentication, and then it was writing back to that same feature service. So all of those things are pretty straightforward to do inside a workflow like this. But I do think that there's going to be some ArcGIS integrations here soon. And so the other thing to take away from this is this idea of using multiple models is incredibly powerful. For processes like this where the information is deterministic. Like I know that number is 001, it is 3, it is whatever. Um, but also, and maybe especially for um, when the data you're extracting might vary slightly. So if you're reading a piece of text and trying to find out, is this text valuable to me in some way? Does it talk about this subject? Does it do something? Each of these models has biases in different ways. So they lean one way or the other in different ways. And by running a summary through both ChatGPT and Claude and then combining those, you're getting kind of the best of both worlds. You're getting information from both of those models. It's like, excuse me, it's like going to you know, two of your coworkers or two of your friends and asking them to read an email or read a document before you send it, right? If it's really important, you might ask more than one of them to read it and give you feedback. Same thing here. We're using different models to read it and give you feedback before you make your final determination or you release the final thing or whatever you're doing in your workflow here. Okay. So that was super fun. I really like building these. If you don't know where to start with a workflow like this, Claude is actually really good at writing the JSON. So you can actually go to Claude, you can say, build me a workflow that does X, Y, Z, and then you go over here and you say import from file and upload the JSON and it'll spit it all in. And then you can hit tidy and it'll organize it. And then you can kind of explore the workflow and figure out what did it do and do I like it or not? I actually did this just yesterday, building the retreat food decider. I didn't actually like what Claude did at all. I threw all of it out, but it did kind of help my brainstorming process. It did help me get into the groove a little bit. So that's even though I didn't take from that specifically, I did take some of its ideas, like reading and writing out of a Google Sheet, something I hadn't tried in an 8N before. So I did take some of its ideas and incorporate them, but I didn't use what it put. And actually, that's a really good one because it showcases something a little bit different. Um, and so what's different about it is we're using tools in an AI agent. So in the other workflow, we were processing the image, we're sending the image to the AI, asking it to do a task and return a result, just like one shot. Here's the input, do the thing, give me the answer. You can also ask agents to use tools. So in this case, this is my restaurant negotiator or my restaurant arbitrator. In this case, the AI agent is connected to 3 different tools. So this first one here is get all current assignments. So that's query the Google Sheet and tell me who's assigned to what restaurant. So give me the full list, right? There's only like 15 of us at the retreat or 16 of us at the retreat, so it's I can just query it all every time. And the second tool is update row. So this allows the AI to go in and change based on name. So it can go look at Christopher and it can change what restaurant I'm assigned to. And then the third tool, and this is where it gets a little fun, is it can search its own chat history across all of the chats that everyone is having with the AI. So the way this works is anybody at the retreat can pull up a chat with the AI and can try to convince it to move yourself to a different restaurant, but it doesn't know who you are. So first you have to identify yourself. You have to prove who you are to the AI, and it has inside its prompt, it has some information like where you're from and stuff like that that it can use to question you. But then it needs proof that you are okay to swap with somebody. Like if I was going to swap with Holly, it would need Holly to validate that. So Holly would have to actually go and have a separate chat with the AI. And the way that it facilitates that is with a code word. So it's super fun. So like last night when I was testing this, it gave me the code word pancakes. And so I had to open up a separate chat as someone else. I had to prove who I was, and then I had to give it the code word pancakes for it to actually validate it. And then what it did is it actually went ahead and executed the swap for me. So anyway, so this just all of that to say that the another way that you can interact with an AI is by giving it tools to call. And this is similar to the concept of MCP, model context protocol. But inside NAN, I can assign these tools directly to that agent and let it call them. And so it's kind of two different ways that you can use an AI in this environment. You can kind of, here's an input, do a task, give me the output, or you can have it call these tools, and it will sit here and iterate and call these tools to take multiple actions. So like, for example, doing a swap of restaurants requires that it changes both my row and Holly's row, for example. So it has to do both of those. Okay. Um, Yeah, so I'm building these constantly. I'm building all kinds of new AI workflows like this and experimenting with it because it's easy to find out, does it work for doing this kind of task? And then I can take that and I can convert it to code later. I could export this in a workflow. I could go to Claude and I could say, write me some code that'll execute this in Python, or I could convert it to a bigger system if this didn't give me the flexibility that I wanted. Okay. I think that pretty much takes care of all of the things I was going to walk through here. So we'll switch to question mode. Oh, before I do, let me pull up the whisper frame. Looks kind of amusing. We'll see. There we go. Oh yeah, okay. So that's like, it's kind of like trying to draw a little camera, low-powered device reading serial numbers. That's kind of cute. Okay, it tried. It got the vibe. Um, yeah, this is my one of my favorite mugs, Mom. Anyway, so okay, so let's switch to questions here. Uh, Turn off my screen share and kind of go through some of these. Okay, so the first question is what are alternatives to front-end development with JavaScript? So I think there's a couple of ways to think about this. So one, there's multiple JavaScript front-end frameworks. There are there's things like React, which is super popular. That's what Experience Builder is built in. But it's also very complicated and is also kind of a mental shift, so to speak, because it is reactive. So your UI reacts to changes in data. You press a button, it changes a data component that's shared across UI elements, and then the UI element reacts to that change. That's where it got its name, is React. So it's very different. It's a different model to think about. The other big popular one is Angular, although I think I think a lot of people consider it to be old. I still like it because it follows that model view controller paradigm, and it's very straightforward for building things. So I do like React. Both of those can work in both JavaScript or TypeScript. TypeScript being a version of JavaScript that is strongly typed. So you can say, this is a number, and I want it to always be a number. And the compiler will help you. It'll be like, oh, there's a problem here. It's not a number in this scenario. What are you going to do? Whereas in JavaScript, you can start something out as a number and it can become a string. So or the parameter that you pass into a function could be a number or a string. You don't know what's coming. So you have that typing in TypeScript. There's also another library called Vue.js, which is pretty popular and also fun to build in. Outside of JavaScript, the concept, the things that you can do start to dwindle. So there are some weird fun things like so there's this thing called WebAssembly in your browser, and what WebAssembly is a standard for executing assembly language inside your browser. It's a very special version of assembly language, but it is essentially that. It's very low level. So it's not like JavaScript. It's low level. And many languages can compile into WebAssembly. And so it is possible to build interactive front ends by writing in some other language, compiling to WebAssembly and running that language. So for example, there's a Python project that lets you do that. Not that I would do it. Python's kind of heavy in the browser, requires a lot of memory and big footprint. So I wouldn't recommend it, but it's a fun experiment. And for short, easy things, it's totally doable. There's also that WebAssembly has also powered .NET. So if you're a C# developer, you can build WebAssembly apps where you're writing in C#, you compile it and deploy it as a set of DLLs in your web application, and it goes off and executes that way. And they take care of all the JavaScript interop because you do still have to have some JavaScript. But in the C# or .NET land, that Blazor takes care of that for you. That's the Microsoft technology is called Blazor. And so they take care of that for you. There's another way you can do this also. And Blazor has this as another mode, but there's other systems. And trying to think, I think it's Plotly was the first time I experienced this. Plotly started out as a Python library for plotting graphs, but it has a web server attachment to it, to where you can write everything in Python and it will generate the web page for you and push it. So it is even interactive. You can click a button on the web app, and what happens is that button triggers a call that goes to your back end and executes some Python and gets the result and sends it back to the front end. So they've taken care of all that JavaScript and routing for you. The trade-off is that it's limited in what it can do. Blazor also has a mode like that, so you can also operate that way in .NET. So those are kind of some of the options from the kind of span from different ways to use JavaScript to I don't want to use JavaScript. If you don't want to use JavaScript, I think you're either in Python or you're in .NET. I think those are kind of the best ways. There are some like data specific languages like Julia and things like that, or R, that can also build UI components, and all of those all work, but they're very niche and very specific. So if you're into those, use them. But if you're not, I'd stick with one of the kind of mainstream languages that are going to feel similar. JavaScript, C#, Python. They're going to feel very similar, even though their syntax is different. Okay. All right. So, okay, the next question is actually, what are your thoughts on environmental impacts of AI? That's a big question. So we're gonna do the third question first and come back to that one because I just got these three that I'm going to cover today. So the third one is, what is the most useful AI tool or use of AI for WebGIS content creator and ArcGIS Online? Okay, so there are two easy ones here. The first is Survey123 AI app, AI assistant, AI form builder thing. I use that as my first pass every single time when I'm building a Survey123 now, unless I'm doing something very complex that has to be built in the Excel spreadsheet in the back end. But if I'm building it on the web, I start with that app, the AI app builder, every time. And the thing that I wish it did is I wish it could edit an existing one. It can only create new. So you can't have an ongoing conversation with it. Instead, it's kind of a one-shot deal. You ask it to build it, it builds it, and then from there, you're kind of editing on your own. But for our retreat next week, we have lightning talks. I wanted a form for people to submit those, so it wasn't just floating in my email. That took me like 1 minute. I went to the AI builder. I described what I was doing. It spit it out. I just had to reword a few things, get rid of a block here and there, and I was done in just a couple of minutes. So like that's much faster than it would have taken me to build that same workflow elsewhere. It's caused me to kind of change behaviors there where I will build a Survey123 a lot, even if I'm going to build a custom app that's going to depend on feature services, I might go to the survey 1, 2, 3 in order to build the feature services or build at least the proof of concept version of those feature services for me, because I can get the AI to build the survey 1, 2, 3, and the survey 1, 2, 3 will build those feature services. So sometimes I'm actually doing it to get the feature services. I don't actually care about the way the UI looks. I just want to define all of the inputs, and I want to do it with the AI so that it can fill in the gaps for me. I don't have to think about every single field. And then I tweak it, I publish it, it builds those feature services, and then I consume that however I want to. That's a common pattern that I do these days. The second obvious one, I think, is the Arcade Assistant. I demoed that a session or two, a live last month or the month before, I don't remember. Well, we looked at that. It didn't do what I wanted it to do, but it is still quite useful and quite powerful. And the third way that I use this all the time is the Arcade Assistant is great in limited examples, but when I want to do something really complex in Arcade, I often go to Claude. And the thing is that it's gonna get some of the function calls wrong. It's not gonna hit it quite right. But it's more flexible than the Esri Arcade Assistant is. And so what I can do is I can like open up the REST endpoint for the layer that I'm using, copy and paste all that content, paste that into Claude along with some information about what I want it to do, and then have it build what I want, go back, paste that into the Arcade editor. And then from there, now I have the IntelliSense and I have the list of functions, and I can kind of clean it up and make it go. So that the Arcade Assistant has value, but then I also definitely use Claude to kind of fill that gap. Then the last way and the less obvious way is I use Claude or my custom app builder to build UI for maps all the time, because to me, it's faster to build a short HTML page that does exactly what I want than it is to try to get Experience Builder to do what I want. And that might be because I'm just not super good at Experience Builder, but I prefer to build the UI or have the AI build simple UIs in just writing HTML and JavaScript. And that's why I built my app builder. And that's like, yeah, I do that probably almost every day, doing different tools. So that's kind of, I think those are my top hits. Okay, back to that second question. What are my thoughts on the environmental impacts of AI? So this is kind of a loaded question, I think, and I think it gets confused and conflated with other things, and it's hard to talk about. But I think fundamentally, there's several ways to look at this, and the way that I choose to look at it as the environmental impact of AI is a solvable thing. I don't want AI to go away. I think that it has changed the way I work. It changing the way my company works. So I don't want it to go away. It's an efficiency. It's a change in approach. It's a thing that I learn so much from it. Like it's incredibly powerful. I don't want it to go away. So what that means is that if AI has negative environmental impact, what I want that reflected in the price. And to get it reflected in the price, I need the companies to be responsible about their environmental impact of AI. And probably what that means is government regulation. So, for example, in the European Union, there are some regulations that have been passed and are coming in both the member states as well as the organization as a whole to encourage AI companies that have data centers in Europe to have those data centers recycle water for cooling. So this is the number one. I guess there's two kind of environmental impacts from AI. The first is water. It takes water to cool the chips to train or do inference. And most new data centers, they're doing closed loop systems. So it doesn't take as much fresh water coming into the system because you cool it off on your own and you bring it back. The other ways that you can get rid of this, and this was a demo at the Esri user conference. So by the time Esri's demoing it, you know that people are thinking about it. Um, you have a whole bunch of hot water coming out of a system like an AI training data center. You can use that hot water to do other things like heat homes or provide heating to nearby universities or nearby large complexes. So you can actually sell them the hot water and take cold water back in. So again, you're building more of a closed system, and that waste heat is going to positive use. And I think those are the kinds of things to look at. The second kind of impact is it takes a lot of electricity to run these things. And that causes an increase in fossil fuel usage because of increase in electrical usage. Like there's some estimates, I think, that are saying that it's something like this. I'm going to get these numbers wrong, but it's something like by the end of 2026, AI energy consumption, if you group all data centers together, it would be like the number 3 energy consumer in the world if it were a country. But I think I think that's double counting, because then I think some of those countries have those data centers. You have to make sure you subtract it. I'm not sure how that actually is working. Needs a little research to understand, but that's all. Regardless, it's a lot of energy. And so I think, again, though, I think we generally are consuming more electricity as we spend more time online and more time streaming. And I tried to find the source for this morning, and I couldn't find it, but I've been doing some research on how much energy does it take to do inference in AI, and one of the things that I've seen talked about is streaming a Netflix episode for an hour is less energy consumption, or is more energy consumption than the average person chatting with ChatGPT about a topic for an hour. Now that's excluding the training cost, but that inference it's less than the impact of streaming Netflix. So I think that, one, we have to keep talking about this, and we have to keep leaning towards better energy sources. There's like Microsoft trying to reopen 3 Mile Island, which I think is great, because I think we've learned a lot about nuclear power, and we can do that in a safe way now. While researching that, I found that there's a Palisades nuclear generation facility, I think it's in Michigan, that's back online this year, like 2 months ago, is back online. And that's driven by data centers needing more energy. And so the thing that I like about those is those are both very clean ways to generate electricity, and we can manage them. So I think that we're seeing positive impact in that direction also. And I think we'll continue to see more people looking at wind and solar and batteries and things like that also. But ultimately, the way I want to think about this is I want that cost reflected in the price. So if that means that the price of using AI goes up, that's okay, because I want all of that impact reflected in the price. It's kind of like buying carbon offsets or something like that. And that's like a whole nother bucket of worms I don't want to get into, but it's kind of like that. I want that built into the pricing. And that's really, I think, the best way to talk about it at the end of the day. So I'm not going to stop using AI. I do think about that. I do think about the environmental impacts of AI. But it also, in thinking about it, it also causes me to think about, well, what's the environmental impact of streaming Netflix for an hour? Because that also has an impact that I had not been thinking about. And anytime I'm using a computer or doing an external cloud resource, I spin up a cloud resource to do something, that is energy and hot water that has environmental impact, not just when AI does it. So it has caused me to think about that a little bit more and be like, well, okay, maybe I needed an excuse to not watch that Netflix episode and go outside and do something else. Okay, if that's my excuse is I want to have less environmental impact, then that's my excuse. It's a good motivator. Okay, that's it for this month, everybody. So thank you for coming. November is going to be a little bit later than normal. Normally, it's like the first week of the month. In November, it's going to be a little bit later because I've got some travel and a local meetup that I've got to run here in Portland. also about AI. That'll be fun. If you're local in Portland, check that out on our events page because we're going to do that in person. Um, and so, yeah, so it'll be a little bit later, but we're still going to do it. Maybe I'll show off some Halloween stuff. Maybe we'll definitely do another AI demo of some kind. So, okay. Thank you everyone for coming, and we'll see you all in November. Thanks.